Hello everyone. The topic of today's video lecture is introduction of cam and follower. So, first of all, what is cam? How will you define the cam and follower? A cam is a rotating machine element which gives reciprocating or oscillating motion to another element known as follower. The cam and the follower have a line contact and constitute a higher pair at the point of contact. The cams are usually rotated at uniform speed by a shaft, but the follower motion is predetermined and will be according to the shape of the cam. The cam and follower is one of the simplest as well as one of the most important mechanism found in modern machinery today. The cams are widely used for operating inlet and outlet valves of internal combustion engine. As you can see in this picture, the valves are operating by the cam. At the time of suction stroke, only inlet valve will open, and at the time of exhaust stroke, only outlet valve will open, and for remaining strokes, both valve will be closed. So there are many examples also, and you can see here the follower is rise. Now second one is return when the follower is down. So now you can see. And third one, when the follower is stationary, or we can say there is no movement. So again, this is rise, follower rise, return, and dwell. This is a cam, this is follower, guides. So this is the link 1 fixed link, again link 1 fixed link guide, and this is link 2 that is cam, and link 3 that is follower. So first kinematic pair between link 1 and link 2 is a turning pair. All turning pair are surface contact. So this is the lower pair, and we will put j is equal to 1. And second, you can see that the kinematic pair between link 2 and link 3, that is a sliding pair, and we can say line contact or point contact will be here. So this is a higher pair, and we'll put h is equal to 1. And third, the kinematic pair between link 3 and link 1, guide and follower. So this is a sliding pair, and this is surface contact. So we'll put again j is equal to 1. So overall we have number of links are 3. J, that is lower pair, are 2, and 1 is higher pair at contact of follower and cam. So we'll put these all values in the equation, that is Kurzbach equation, and we will find out the degree of freedom, or we can say the mobility of the linkage. So we'll all put the data in this equation, and we'll get F is equal to 1. So the mobility of this linkage is 1. So one will be the output, and one will be this classification of cam. So in this classification, you can see according to shape, according to follower movement, according to manner of constraint of the follower. So one by one we will discuss all this cam. So first is wedge cam. So here you can see the wedge cam W has a translation motion, and the follower F can either translate or oscillate. Second one is radial or disc cam. A cam in which the follower moves radially from the center of rotation of the cam is known as a radial or disc cam. Radial cams are very popular due to their simplicity and compactness. Third one is spiral cam. It is a face cam in which a groove is cut in the form of spiral. The spiral groove consists of teeth which mesh with a pin gear follower, and very limited use of this type of cam. Next is cylindrical cam. In this type of cam, a cylinder which has a circumferential contour cut in the surface rotated about its axis. The follower motion can be of two types as follow. In first type of cam, you can see the follower is having oscillating motion, and in second type of cam, the end of the cylinder is working surface. We have cut it in an inclined surface, and a spring loaded follower translates along or parallel to axis of rotation. Next one is conjugate cams. This is a double disc cam, the two discs being keyed together and are in constant touch with the two rollers of the follower. Thus, the follower has a positive constraints. Next one is globoidal caps. Same like the cylindrical cam, but the surface are different. As you can see, convex and concave. These types of cam is limited to moderate speeds, and when the angle of oscillations of the follower is large. And this is the last one, that is spherical cam. This is in the form of a spherical surface which transmit motion to the follower according to the follower movement. So in this you can see R return, rise, return, rise. So in this, an alternate rise and return of the follower. So first is right, second one is return. Again for the next cycle, again rise and return. So alternate rise and return of the follower. After the second one is dwell, rise, return, dwell. So in this, a rise and return of the follower after dwell. So first dwell, rise, return, again dwell, rise, return. So this will be the motion of the follower. After the next one is dwell, rise, dwell, return, dwell. So in this, the dwelling of the cam is followed by rise and dwell, and subsequently by return and dwell. You can see in this picture. Yes. And last one is dwell, rise, dwell. So in this, the return of the follower is by the fall. Okay, so the motion may be as dwell, rise according to manner of constraint of the follower. So to produce exactly the motion transmitted by the cam to the follower, it is necessary that the two remains in touch at all speeds and at all the times. So first one is spring loaded, preloaded spring cam. In this, a compression spring is used for the purpose of keeping the contact between the cam and the follower. And second one is positive drive cam. So in this type of cam, a constant touch between the cam and follower is maintained by a roller follower operating in the groove of the cam. Also, the follower cannot go out of this groove. So this is a positive drive cam. And last is gravity cam. So due to the force of gravity or due to the weight, the contact is created. So next one is the classification of the follower. Same in this, according to surface and contact, according to motion of the follower, according to the path of the motion of the follower. So we'll discuss one by one. So first is knife edge follower. So it is a quite simple in construction, but there is a great wear of the surface at the point of contact, as the sliding friction is there. So there is more wear, tear. Okay, so there is a great wear. Second one is roller follower. It has a cylindrical roller free to rotate about a pin joint at low speeds. The follower has a pure rolling action, but at high speeds, some sliding also occurs. So pure rolling will not possible at high speed. And in case of steep rise, a roller follower jams and cam, and therefore it is not preferred. Next one is flat face follower. The advantage of this follower, it does not poses the problem of jamming the cam, but high surface stress and wear are high here. And last one is spherical face follower. So the disadvantage of the flat face follower of high wear is reduced in this type of cam by providing spherical face according to the motion of the follower. So in this you can see there is reciprocating follower and oscillating follower. The first one is reciprocating follower. So in this the cam rotate and the follower reciprocates or translates in guides. And the second, the follower is provided at suitable point on the frame and oscillates as the cam makes the rotary motion according to path of the motion of the follower. So in this you can see radial follower and offset follower. So radial follower, in this the radial position or we can say the line of the movement of the follower passes through the center of rotation of the cam. Okay, and in second one, the line of movement of the roller follower is offset from the center of the rotation of the cam. Here is a short animation. In this you can see. Next one is definitions. So we'll discuss about the definitions in the cam. So we have taken that radial cam. So in this first the cam profile, and this is the base circle. So base circle is the smallest circle tangent to the cam profile drawn from the center of rotation of a radial cam. Now this is a follower and this is a trace point. So a trace point is a reference point on the follower to trace the cam profile. Like this is a roller follower, so the center of the roller will be trace point. This is a pitch curve. It is a curve drawn by the trace point, assuming that the cam is fixed and the trace point of the follower rotates around the cam. Now next is a prime circle. So same like this is again a smaller circle drawn tangent to pitch curve is known as prime circle. Now this is the pressure angle. So the pressure angle is simply the angle between normal to the pitch curve at the point and the direction of the follower motion. It varies in magnitude and at the all instant of the follower motion. A higher value of or maximum pressure angle is not desired, as it might jam the follower in the bearings. As in the picture you can see this is maximum pressure angle and the trace point is pitch point. So the pitch point is the point on the pitch curve at which the pressure angle is maximum, and this is pitch circle. So it is the circle passing through the pitch point and concentric with the base circle. Now next is a displacement diagram for different type of follower motion. So there are four motions: simple harmonic motion, constant acceleration, deceleration, constant velocity, and cycloidal. So in this, first we will discuss about simple harmonic motion. In this, you can see here a rectangular box in which horizontal is of angle of ascent and vertical of the follower. So we will make a 6 part of this. After then, this is SHM. So we'll make a semicircle at the starting point, and we'll divide this in 6 part, 30 degree angle, and we'll join all the lines. We have to mark at the 1 1 2 2 the point of intersection of the two lines. So we'll get all the points and we'll join all the points. So this is a curvature for simple harmonic motion. The follower will follow this curve. And if you want to find out the maximum velocity and acceleration on the curvature of the follower motion, then there are two formulas for velocity maximum and acceleration maximum. You can find the value of maximum velocity and acceleration by this formula. Next is constant acceleration and deceleration. So in this, first half is constant acceleration and second half is constant deceleration. So again, we will make we'll divide in 6 part, and the vertical line at the center, again we will make in 6 part. After then, we'll make a diagonal, we'll join all the lines, and we mark the points at the intersection, and we'll make a curve. So this curve is in the first half this is constant acceleration, in second half this is constant deceleration, and these are the formula for maximum velocity. And because this is constant acceleration, there will be no maximum acceleration. The acceleration will be constant throughout the motion. Next one is constant velocity. So in this, the displacement of the follower is proportional to the cam displacement, and the slope of the displacement curve is constant. So in this, again 6 part, again vertical 6 part, we'll all join all the lines, we'll mark the points, and we'll join all the points. So this is a constant velocity, and there is no acceleration because velocity is constant. And if you have to find out the velocity, then you can find out the velocity by the formula. Next is cycloidal. So in this, a cycloidal is the locus of the point on a circle rolling on a straight line. So in this, you can see the periphery of the circle will be equal to the height, or we can say lift. So in this case, the rolling should be pure rolling, and we have to find out the radius of the circle. So the radius will be h upon 2 pi. So again, in this we will make 8 part. The circle will divide in 8 parts of circles. After then, we will make common points for 2. No, 2, there is only 1.2 and 6, but remaining 5 7 will have one common point. 0 4 8 will have one common point. 1 and 3 will have one common point. So we'll make all the parallel lines, and we'll mark the points and join the points. So we'll get the cycloidal profile, and by this formulas we were able to find out maximum velocity.